Good morning. Hello, Internet. How's my audio? Good morning. Oh, I'm echoing. Let me turn that off. There we go. All right. Well, welcome, everyone. For those of you who don't already know, I'm Steven Frank. I'm one of the co-founders of Panic, the company making the Playdate. Cable and I started the company about 70 million years ago during the Mesozoic era when the dinosaurs were still roaming the earth. We started out by making Mac software and of course gradually got into iOS, apps for the iPhone and iPad. Got on a weird detour into game publishing. We published the games Firewatch and Untitled Goose Game recently. And then Playdate is going to be our first kind of ever real foray into hardware. It was a crazy idea that we had, and we're going to try it out and see how it goes. I'm excited to talk to people about it for kind of the first time from a developer perspective. Little bit of housekeeping. I'm working from home, of course, so there might be a little background noise. You might hear some the screeches of happy children or some dog barking. I ask your forgiveness for that. Also, I have the chat open, but it's kind of off to the side, so I might not see your questions. Forgive me for that, but there are Panic people lurking in the chat who hopefully will be able to answer your questions if I don't. So we recently had kind of a little random selection process where a limited number of units are going out to some early access developers. And those are kind of just starting to trickle out. They will be showing up more and more through the month of May. But these are basically, they're basically the same units that the end customers are going to get, but without any of the games on them. Because all Playdates are developer units. Any Playdate can be used for development. And all Playdates support sideloading, which means you just can plug it into USB, copy your game onto it, and you're good to go. You don't have to go through us to distribute your game, although we will probably be curating collections of games into seasons as time goes on. The details of that are still a little bit in flux, so we'll have more to talk about that in a little while. Let's see. So today I'm going to talk about, first of all, just installing the Playdate SDK and setting up the bare bones development environment on a Mac. The SDK will also be available for Windows, and we even have a Linux version that's kind of in an alpha stage right now. And we'll see how that goes, but I'm optimistic that we might be able to get it to run on that as well. So it'll be a good low barrier to entry for anyone who wants to write a Playdate game. I'm gonna show you how to write some code in Lua. Lua and C are the two languages that we support for developing on Playdate. And probably the more experienced programmers among you are already thinking, oh, I'm gonna go straight to C. I don't need to mess around with Lua and so on. But I would actually encourage you to check out the Lua interface first. You can get some pretty decent performance out of it, and it's much simpler than writing to the C interface. If you've never used Lua before, it's a very simple language to learn. I would encourage you to, you can check out the docs. I think it's lua.org. But my advice is when you're learning it, don't go too far. It gets into some really kind of like abstract stuff. Things like meta tables and coroutines and yada yada by the end of the programmer's guide, and you don't really need to know any of that stuff to write a really good game. If you follow me on Twitter, you may have seen recently I wrote a little video poker game over a weekend for a game jam, and that was all done in Lua, about 2,000 lines of code. And obviously, a video poker game is not very demanding, but all the effects, everything runs at 30 frames per second, and I didn't have to think about C or memory management or any of that stuff. So I encourage you to give it a shot. So we're going to write some simple Lua code, test it in the simulator, and show you how to run it on the device. All right, enough talking. Let's go do the thing. So I have a copy of the Playdate SDK installer here. On the Mac, it comes in a standard installer package. And so let's just go ahead and run it. Install. My voice is my password. And we're done. Easy. Let's keep the installer for now. And that's going to make a folder in my home directory called developer and put Playdate SDK in there. It doesn't have to stay there. You can, where's my terminal? You can actually move that folder anywhere you want, but the only thing you have to keep in mind is to update this file called .playdate/config, which tells the rest of the tools where to find the SDK. Okay, so let's take a quick look at what is in the SDK folder. The top folder here is the binaries. The font tool is a little helper application for designing your own pixel fonts and making sure they're aligned correctly and exporting them into a format that the Playdate compiler can use. So we don't just take off the shelf TrueType fonts or anything like that. There is a little bit of manual work there, but it's not super difficult. PDC is the Playdate compiler, which is a command line tool. And what PDC does is you pass it an input folder, and it spits out what's called a PDX file. Actually, a PDX folder. It contains basically bytecode compiled versions of your Lua and optimized images and all of the other assets like that, and wraps it up into a little bundle that can then be run on the simulator or on the device, the same file. I'll show you a little bit about how that works in a moment. The simulator is very much akin to the iPhone simulator. If you've ever done iPhone development, it's just a simulated device that runs on your screen and offers the same API as the actual device. So you don't have to be constantly transferring your game to the device to test it. The only thing to keep in mind is the simulator does run at the speed of your computer and not the speed of the device. So although you can run at the same frame rate, you may be able to get a lot more done per frame on a computer than you can on an actual Playdate. So we encourage you to test on actual hardware early and often to make sure you're getting the performance that you want. Playdate.Nova extension. So Nova is our text editor / IDE that we've been working on. This is a general purpose IDE text editor environment that's going to be used for web developers, all kinds of things. But we also figured, well, why not make this sort of the center point for our Playdate SDK? And this is an extension for Nova, which makes it very easy for you to build and run your game from within the editor. I just go ahead and double click that to install it now. So do I want to install the extension or open it for editing? I want to install it. And there's my installed extension in Nova, so I'm good to go. These are some beta binaries for Windows. There's information here on the C API that we're not going to get into today, but there it is. Core libs is basically a set of utility functions, libraries that are all written in Lua that you can take advantage of if you want, or you can just ignore them. It has, for example, we have a little bit of a sprite library that you can use for managing and updating your sprites, or you can just ignore that completely and do all your own drawing. Things like timers, animation timelines. So if you have something that animates on a curve, like an ease in or ease out curve, that's something we can provide for you. Some UI things, a 9-slice, if you've never heard the term before, it's a box that's, it's basically the border of a box. So you do the 4 corners and the 4 edges and the center, and then that can be drawn at any arbitrary size. And you can have a cool looking rectangular box. The crank indicator is a little just helper utility that pops up in the corner of the screen and says crank to continue or something like that. It's a little prod to your users about what to do next. Anyway, it's just kind of a grab bag of stuff that we've already written that you can choose to use in your game or not. The disk folder, this is just basically what's on the flash memory of the device. So this is things like the launcher and the settings program that are used on the Playdate. There's copies of them here because the simulator uses them. There's a folder with a bunch of examples of just different kinds of things. I won't get into too much detail on that. The firmware I don't think is going to be there on the final SDK release, but it's here on mine. And then this is a very important document called Inside Playdate. This is our big reference manual on all of the different things that are available in our API to you as the game developer. It starts out talking a little bit about the process, a little bit about Lua, and then it gets kind of right into API reference. So here's a section on how to read the crank, how to store data for your game saves and whatnot. File system operations. So if your game has data files like levels or maps that it needs to load at runtime, that's how you do that. All of the different geometry things that it can do, affine transforms, arcs and circles, lines, points, polygons, rectangles, and so on. Graphics, it talks about image drawing, doing transformations and masking, drawing color and pattern. Obviously, there's only two colors, black and white. It is a 1-bit device. There is no shades of gray, but due to the density of the display, dithered patterns read really well, and I definitely recommend taking advantage of that in your game. There's a bunch of other stuff, animation, loops. We have a thing called an image table, which is basically, it's kind of like a sprite atlas, series of images in a row, where you can say, I want to just loop these images and animate them, and that can be used in conjunction with a sprite if you want to do that. Or again, you can roll your own. Tile maps, we have some built-in support for drawing tile maps, which is pretty nice. Here's a big section all about sprites, and if you want to use our sprite library, how collision detection and things work with that, and drawing text and using fonts. Under sound, a couple of interesting things. You can play just regular old samples. You can play background music using a file player, which is for a larger file that you kind of want to stream from the disk. And although the device is capable of playing an MP3, it is a pretty high CPU load. So what we recommend is you convert your music and your other long music file or long audio files into a format called ADPCM. And that can be done with any number of free open source utilities. You can use Audacity for that. I've done it with FFmpeg. And that is a much faster thing for the CPU on the device to decode. And so it's a big performance win to convert your audio to that format. We have a built-in synthesis engine for certain things. So you can say, I'd like to play a sine wave or a square wave at this particular frequency and with this attack, delay, sustain, and release. It's really cool, and hopefully I can give you an example of that a bit later. There's even some sound filters, 1 and 2 pole filters, ring modulator, bit crusher. There's a little bit of audio stuff for sequencing music tracks. I think this is still a little bit in beta at this point. I tried to use it recently. It didn't work out so well, but the idea, at least the API is there, and we'll continue to flesh that out. Mic input. The device has a mic. You can record to a buffer and play it back, or just get the overall input level from the mic. that lets you kind of, you can use that to do tricks like blow on your device and measure the input level to see if that's something, if the user's blowing on the microphone. And the rest of this is kind of utility stuff, strings, timers. So, I want to have something that happens every 2 seconds or something like that. You can configure that. But anyway, inside Playdate, it's an HTML file, just kind of self-contained, very good to have bookmarked as you're working. In this resources folder, we have some default fonts that we provide. You're welcome to use these if you want. If you don't have your own font or you don't want to design your own font, these are some ones that Nevin made for us. And we're going to ship these with the system and the SDK, and you can just use these if you want. And the images folder has some bitmap patterns that may look familiar if you've ever used something like MacPaint. These are also handy to have around for, drawing patterned shapes and so on. All right. Moving along, let's start writing some code. So I'm going to open up Nova. This is probably the first time a lot of you are seeing this too. It's not shipping yet. Hopefully soon. It's getting very close to done. You don't need to use Nova. Any text editor will work, and I'll show you how a little bit later. For now, I'm going to say I want a new project, and let's just throw it on the desktop, and we're just going to make a box that moves around the screen for now. So I'll just call it box mover, and we'll save it there. And the only file you actually need, you can have as many as you want, of course, but the only file you actually need is one called main.lua. And this is the first script that the engine will load and run for your game. And in main.lua, there's actually only one function you have to implement, and that is a function called playdate.update. So playdate.update gets called every time the system is ready for a new frame, and that's where you update your world, all your behind-the-scenes stuff, and draw it onto the screen. Okay. So we'll use some of the simple built-in geometry APIs to just draw a rectangle. So we'll say all of the functions are namespaced to a Playdate namespace. So in this case, it's playdate.graphics. We'll set the color to black. And you're probably already thinking, what is this Playdate.graphics everywhere? That's really annoying. So what most people do is make a variable that's a shorthand called something like GFX, and just assign that to be Playdate.graphics. And then instead of typing Playdate.graphics everywhere, you can just type GFX. Okay. Let's, actually I'm in an untitled file, so I'm going to copy that over to my main.lua. Save. Okay, so how do I run this? Well, this is where it's nice if you happen to be using Nova, because I can click this to get my project settings. And under the build and run section, I can just add a Playdate simulator to this project. And I don't have to change any of these settings unless I want to. I can just hit done. And now I've got a toolbar up at the top, which will let me run this, and there's my box. This is the main window of the simulator, the yellow one. The controls are all live, or you can use the arrow keys on the keyboard. This is a little bit confusing that it says A and S. This is actually on the physical device. This is the A button. This is the B button. But this is indicating you can use the A and S keys on the keyboard to simulate those buttons. These controls down at the bottom let you pause and restart your game. This turns the debugging console on if it's hidden. There's a little time profiler, a little sampler that you can use if you're having performance issues, as well as a memory graph that will show you the kind of all the Lua objects that exist in your Lua runtime. This little guy makes an animated GIF if you want to record a portion of your game and share it. And this is the serial number of my device that is attached. You can see in the lower right corner of your screen. Okay, this is a functional game. It's not very exciting, so let's do some movement. Oh, one thing before I move on, I want to show you what the output of the compiler was. It's this file right here called the .pdx. And although it appears to be a file, it's actually a folder with a .pdx extension, kind of like an app bundle on the Mac, if you've ever done that. So if I actually open this boxmover.pdx folder, inside I see two items, main.pdx, which is an actual file called pdx, and this is my compiled version of main.lua. And the pdx info file is like a little metadata file. It's just kind of put in some default values for me here, but this metadata is used by the launcher on the device to set what's the name of the game, who's the developer, copyright information, and what SDK version it was targeting for compatibility reasons, so we don't try to run you on a device that's not on the right firmware version. And just to sort of demonstrate that I don't need to use Nova in particular, let's delete our PDX, pop over to terminal, and we'll go to our desktop box mover, and we can use VI if we want. We'll move our square somewhere else. It's probably going to go off screen now. And the syntax for PDC, we actually want to go one level up and pass the name of the top level folder and what we want the output file to be. And it runs pretty much instantaneously. And there's our PDX file, which if we now run, we should see our square has moved a little bit down and to the right. So yeah, use whichever editor you like. I know that most developers are pretty easygoing about, most developers, they're chill about editors. There, no real preferences there. All right. All right, I'm just looking at the chat. Cable, what are you trying to tell me? Oh, font size bump up on the editor? Oh yeah, that's pretty small, huh? Okay. So the next phase of this should be something like, let's make this move around with the arrows. So I'll pull out our X and Y location into variables called X and Y. And maybe we'll also make the width and height of the box variables too. How's the font size now? I'll just keep going. Okay, there we go. So in our update, we're going to want to look at the inputs. So there are multiple ways you can do this. One way is to just pull the inputs in your update loops. So I can say if Playdate button, what is it? Button is pressed. That's right. Thank you, autocomplete Nova. And button right, for example, is of course, the right arrow on the D-pad. Then we can move it right by 5. And I'll do left as an else if, because obviously you can't be pushing right and left at the same time. Okay. So now we should be able to make this move left and right. But we can't. What did I do wrong? If Playdate.button is pressed. Oh, these constants are also namespaced. That's what I did wrong. Okay, so I can move this left and right now, but you notice it's leaving a trail behind. And the reason for that is it does not automatically clear the screen on each frame. This lets you kind of optimize your drawing. If you are only updating a small portion of the screen, you don't have to redraw the entire screen every frame. And it's a bit gentler to the battery as well to not do that if you can avoid it. So to clear the screen and get rid of that trail, we'll just do a fill rect of the whole screen, which is 400 by 240. And there she goes. And let's round this out by doing up and down as well. Up, down. The origin, the coordinate system origin is of course in the top left, because only a crazy person would design a coordinate system with the origin in the bottom left. Shout out to Apple. Okay, so now I can move my box all over the screen. That's fun. Why not at this point stop and get it running on our device as well? So I'll go up here to my device menu because my device down here is already plugged in, and I apologize, this camera does not want to focus on the screen of this device, and I'm aware of that. I will try to do the best I can. But once it is plugged in on the USB port here, that will automatically be recognized by the simulator, which will cause this device menu to appear. And I just say upload game to device. And it's going to do its thing. It's going to reboot the Playdate. And now if I, oh, it automatically ran it for me. So now I can just move it around. And my $1 million new IP is born. The Box Mover franchise. Okay. There's a variation of button is pressed, which is helpful for certain things like platformers, which is called button just pressed. And button just pressed only returns true if the button was pressed if the button went down on this frame. So in other words, it just went down. If it's held down, this will return false. It only returns true the first time it goes down. So the effect this is going to have is it no longer moves when I hold the button down. I have to tap the button each time. I'll go ahead and back out that change. Okay, but this is a Playdate, so we want to do, it would be fun to do something with the crank. Let's see. What if we make the crank control the size of our square? A couple different ways to read the crank. The crank can be read absolutely, so as a degree value 0 to 360, or I guess 0 to 359. Or as a delta, so it's moved plus 2 degrees or minus 2 degrees relative to where it was the last time we checked. In this case, I'm going to just get the absolute degrees angle of the crank using a function called getCrankPosition. So that's going to give me a number 0 to 359, and we'll set the width and height of our square to, let's say, I don't know, we'll divide that by 3 and add 1 just so it can't go to 0, I guess. Now the way you simulate the crank in the simulator, let me scooch this around, is to pop open this drawer. And this gives you a set of controls for both the accelerometer in the device. This is sort of a simulation of the 3D orientation of the device. And the crank just goes around. Or you can have it automatically rotate for you at different speeds. None of these are great comparing it to an actual device. So if you're doing if you're doing a game that uses the crank, I recommend testing it as much as possible on the actual device because it's a much better experience. Okay, so I didn't recompile this yet. Let's do that. And now we should be able to change the size of our square with the crank. Good. And move it around. Good. Let's run it on the device. And in the current version of the SDK, this little thing that says unmounting gets stuck on the screen for a while, and I think that will go away eventually. But now let's go over here and look at our box mover. And, uh-oh, blank screen. Looks like I found a bug. Well, it works in the simulator. That's the way it's supposed to work on the device. I will just put it back to the launcher for now. So this isn't the only way to get input. It's kind of, it can get a little out of control having all of your input reading right here in your update loop. So there's also the possibility of doing it with callbacks. So if you have these functions defined, the Playdate will call them back when the corresponding input happens. So if I say right button down, this means that the right button on the D-pad has been pressed. It's equivalent to the just pressed. So I can move this in here, and we'll very quickly make 4 of these. Left, up, down button down, delete all of that code, up decrements Y, down increments Y, and left decrements X. And I'm going to take out this crank code since it's not working right now. Dash dash is the comment, inline comment for Lua. And I think I might have screwed up the names of these functions. Let me quickly refer to my inside Playdate. Yep, they are not capitalized. Okay, so yeah, now I'm getting input through those callbacks instead of polling in my update loop. Let's see if there's anything I need to know about get crank position to make that work. Still works in my simulator. Yeah, doesn't like that call for some reason. I wonder if I can convert that to a callback. Yeah, Playdate cranked. That callback is the change in degrees, so it's a little bit different than what I had, but let's give it a try, see if we can get it to work. And since this is now a delta instead of an absolute value, I'll just say let's just add the change value. Try it in the simulator first, works there. See if we have any luck with this version on the device. It runs. Hey, look at that. So now I can move it because my input handlers are still only registering on the down press of the buttons. I can move it one step at a time, and I can crank to adjust the size. How well can you see that? Probably not very well. All right. So this box is all well and good. It's not very exciting. Let's maybe instead of just drawing a box, we will use an image. So I have this file king.ping. And if you saw my video poker game, this was a graphic that I drew for the king face cards. And the version I appear to have here is comically large. It's 2048 pixels square. So let's first of all make that a more manageable size for Playdate. We'll go with 64 by 64. And I'm just going to drop that in the folder next to my source code. Actually, let's make this a bit more organized. We'll make an images folder, and we'll put the ping in there. And we can load our king by saying graphics image new images/king. I don't need to specify the extension because the extension is actually going to be changed by the compiler. It's going to convert from ping, it's going to flatten it down to 1 bit, and it's going to rewrite it in a format that's a little bit more optimized for the device to read than just decoding a ping. So it does go through a bit of a transformation, but you can continue to work with your assets in ping format, and it will convert at compile time. And to draw him, instead of draw rect, we're going to call a draw method on him at xy. And this is a little bit misleading. This makes it seem like there's object-oriented programming in Lua. There isn't. Lua has no notion at all of classes or objects. The only complex data structure it has is called a table, which is just an associative array, a hash. And literally that's it. However, there are ways to make a table that kind of looks like something like an object, which is what we're doing here. But don't be fooled. This is not object-oriented programming, and it just looks like it. And honestly, that's close enough for our intents and purposes. If you go too far down the rabbit hole of trying to make Lua have classes and objects, you kind of just end up confusing yourself because the language is just not built to do that. You can do it. Honestly, I'm not sure it's worth the time. With the SDK, we have implemented a lot of these things as objects because it just makes them easier for you to use. But whether or not you want to use them in your own code is up to you. Anyway, enough talking about that. Let's run this. There's our king. And now we can move him around. Very simple stuff. We don't have to worry about, it's not a GPU, it's just a bitmap. So it's, there's no surfaces or textures or anything like that to worry about. It's just drawing bits to the screen. So let's upload our game to the device again, just so we can take a look at our king. Hopefully this Playdate screen is visible to you. And it's no longer a box mover, it's a king mover. Wonderful. Let's just do one more goofy thing for fun. So I'd like to make a little sound every time we make one of those movement steps. and I'll use the built-in synth API to do that. And all of the sound APIs are under playdate.sound, so I'm going to make an alias to that just like I did for graphics. And we will make a new synthesizer by calling sound.synthNew, and by passing it what type of waveform we want. We'll do a sawtooth. And we will call our synth, what? Typing. We're going to call set ADSR, which is attack, delay, sustain, release, which if you've ever worked with synthesizers before is going to sound familiar. It basically describes the shape of the waveform, how fast does the sound come on, how long does it sustain itself, and how quickly does it go away at the end when it's done. For now, we'll just use these values. And when we're ready to play it, that's all we need to do for setup. I'm gonna say play note, and this takes an argument in hertz. And it's kind of silly to duplicate this everywhere. Obviously, you could do this a bit more intelligently, but for now, make sure my sound is turned up. And you should, there he goes. Okay. And we'll do this on the device as well, just to prove to you that it works. And we'll just boop him around. There he is. And it works on the device as well. You know, not bad. 2 lines of code to set up a synthesizer, and 1 more line to play it. So that's kind of a very broad overview of just how do you get images on screen, how do you respond to input, how do you play sounds, how do you use the crank, kind of all the basics. Let me see. I was also going to, if I had time, I was trying to keep this under an hour, and it looks like we're coming up on 45 minutes. So I will just, rather than type through this next example, I will just go ahead and copy and paste it in. Actually, no need to copy and paste it. I'll just move the whole folder. All right, so this is just a folder stars with a main.lua inside. Drop that on Nova. Add our Playdate build task and run, and now we've got a pretty sweet star field. We'll get that running on the device too. And just give you a quick tour through this code once that's done loading onto the device. Here's stars. Can you see that? There she goes. You notice the simulator has paused because I changed the focus to the editor window. If I click back, it'll resume there. So yeah, this is pretty simple. I will point out a few things because this shows you how to use tables in Lua. So we have this function called init stars, and it's going to set up 100 stars in total, and it's going to store them in a table called stars, which begins life as an empty table. We have to declare it at least as an empty table before we can use it. Here's what a for loop looks like in Lua. It's not too scary. It's just starting number, comma, ending number, and it goes through each of the stars, initializes the star at that index to an empty table, and calls reset on that star. Now I said Lua doesn't have any complex data types other than tables, and you're like, well, this looks like an array to me, and it actually is still a table. But it is just a numerically indexed table, which appears to the casual observer to be the exact same thing as an array. However, one quirk of Lua that gets a lot of complaints is that arrays begin indexing at 1 and not 0. And it's not a big deal. Honestly, you get used to it after like the first couple of times you screw it up, and then you remember, oh, right, it starts at 1. Plus it makes these for loops real easy, because now I don't have to say, this would be 0 to num stars minus 1 otherwise. So it makes it slightly cleaner there. So, all right, 1-based indexing will live. And then the last thing the init does before it leaves is to call move stars, which will give them like 1 tick of movement before returning. So init calls this reset star on all 100 of our stars. So what does reset star do? It says, basically, there's some math here, but at the center of the screen, which is 200, 120, we are going to have a circle. You can kind of see it right here. If I restart, you can kind of see the outline of a circle. And stars are going to be spawned from the edge of that circle. So the spawn radius is how far from the center do these stars spawn, and then we use the sine and cosine of star.a, the angle, which we're setting here, which is in radians. So it's picking a random angle somewhere along the perimeter of that circle and assigning a velocity to it that's a random number somewhere between the minimum and maximum speed, which I've arbitrarily set to 3 and 16. So yeah, for all 100 stars, they're given an initial position on the perimeter of that circle and a velocity and an angle. Okay, skipping downward a little bit. The draw stars function just sets the color to white. Says starting from 1 and go to the number of stars in the array or table. If this is a brand new star, if it has no previous position, it's just been created, these are 0, then just draw it as a pixel. But for the stars that are moving and have already come away from the center, you can see that they are drawn as lines, which gives you kind of a cool motion blur effect. And that's done by drawing a line from the star's current x and y to its x and y previously on the previous frame. And then to move the stars, all we do is we loop over each star. We save off where x and y was before, and we move its current x and y by its velocity times the cosine and sine of the angle that it has. And if it goes off screen, we call reset on it, and which puts it back on the middle circle edge again. And so all the update function does is it clears the screen to black, calls move stars, and calls draw stars. And this little out of band call to init stars will, because this is at the top level of the file, that will fire before any of these other functions get called. So before the first playdate.update happens, init stars will get called, which sets everything up, and then my init loop can just run. All right, I'm about 11:50, so I came in just under an hour. Not too bad. That's pretty much all I had to talk to you about today. I hope this has been fun or interesting, or both. If you have any questions, we can hang out in the chat for a while and try to get those answered for you. Like I said, those early access developer units are going to be kind of trickling out through the month of May. If you won the drawing for one of those. If not, please have patience. We will be producing them again as soon as we can. It's gonna take a little while. Our factory did shut down for a little while due to coronavirus, but they are in the process of coming back up. We are working on some new updates to the firmware that we want to get on these devices before we start shipping them out. So everything has to kind of line up. The planets have to be aligned, and then we will get these out to you, I promise. Please try to have some patience with us as we monkey our way through our first ever hardware launch. That's it. That's all I got. I'm going to close it down and head on over to the chat. Goodbye. Talk to you again soon.